Structural representation of organic compounds. Okay, structure of organic compounds are represented in levies or dot structure and dash structure. Okay, a covalent bond is represented by a dash and single bond is represented by a single dash. Okay, and a double bond is represented by a double dash, and a triple bond is represented by a triple dash. Okay, so three types of bonding. Now there are three types of representation are there. First one is complete structural formula. First one, complete structural formula. Complete. Take one example, ethane. Complete structural formula of ethane is like this. Okay. Carbon and hydrogen are attached by a single bond. Okay. This will be the complete structure of ethane. Okay. Take another example, ethene. Ethene can be represented like it. Ethene contains a double bond. Okay. Compound will be like this. Okay. Take one more example, methanol. Methanol contains an OH group. Okay. The compound will be like this. OH. In the case of oxygen, there are two lone pairs of electrons. Either we can represent like this, or without lone pair also we can represent the compound. Okay. Now the next second type is condensed structural formula. Condensed structural formula. So ethane, the condensed structural formula of ethane is CH3CH3. In this case, the identical groups are written with a subscript. Okay, written with a subscript. Okay, in the case of ethene, this will be C double bond C, H2, H2. Okay, methanol will be CH3OH. This will be the condensed structural formula. Okay, similarly, we can write one more example. CH3, CH2, 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 CH3. We can condense this formula again and write like this: CH3, CH2, 6 times CH3. Okay. This will be the condensed formula. Now, the third representation is bond line structural formula. This is the most simpler representation of structural representation. Okay. Third one, bond line structural formula. Bond line structural formula. How can we draw this? In this case, take one example. CH3, CH2, CH2, CH3. Take one example. In this case, the carbon atoms, the carbon and hydrogen atoms are not shown in the bond line structural formula. Okay. And if oxygen, chlorine, nitrogen, etc. are present in the molecule, they are specifically written. Okay. And the terminal atoms denotes the CH3 group or the methyl group. And the lines representing carbon atoms, are drawn in a zigzag fashion. This means that the junction contains carbon with appropriate hydrogen atoms, and two terminal groups are methyl groups or CH3 groups. If other atoms, if atoms other than carbon and hydrogen are present, like oxygen, chlorine, etc., we are specifically written. Take one example. 2-bromo-butane. How can we draw the structure? 2-bromo-butane. The second position, there is a brominate. Okay, we can draw like this. Take one more example. CH3, CH2, CH2. Take this example. How can we draw the bond line structural formula of this compound? We know that there are 8 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atoms with a CH3 group in the third position. So, the bond line structural formula will be like this. Okay. Third position there will be a CH3. Okay. This will be the structural formula. Now, take few more examples. Cyclic compounds are normally drawn like this. Cyclic compounds. Take one. Cyclopropane. Cyclopropane. CH2. The bond line structure formula will be like this. Okay. Bond line structural formula. Bond line structural formula. Now, take another example. Chlorocyclohexane. Chlorocyclohexane. Compound will be like this. Okay. So, the bond line structural formula will be Cl present. Okay. So, the bond line structure formula will be like this. Okay. Normally, cyclic compounds are drawn like this. Okay. There are lots of other compounds also. So, these are the 3 main types of representation of organic compounds. Next is, how can we draw the 3-dimensional structure of an organic compound? 3D structure. 3D structure. How can we draw the 3D structure of an organic compounds? Okay. The organic molecules are represented in 3D structure upon proper structure using certain conventions such as wedge formula. Wedge formula. Okay. Take one example. Methane. Methane molecule. Okay. Consider this methane molecule as an example. Okay. In this model, the dashed structure and the this is dashed wedge, and this is solid wedge. These two are out of the plane of the paper. Okay, these two are out of the plane of the paper, and the dashed wedge represents bond out of the plane, away from the observer. Out of the plane, away from the observer. Okay, and solid wedge represents bond out of the plane towards the observer. Okay. And the broad end of the solid wedge will be towards the observer, and these two normal lines are on the plane of the paper. These are the different representation of the molecule.